Testing. 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 Trying to see if this audio can hear me. Trying to see if this audio can hear me. Alrighty. Well, everyone, it is I, Alex, and let me just show you what I'm working on right now. So I am playing around with my Raspberry Pi. Now that I've done my API development, excuse me, I decided it was time to go ahead and try to um, get the Raspberry Pi up and running. So as you can see, I've got my Raspberry Pi here, and it's all hooked up and powered up. I've got it hooked up to Wi-Fi, and over on the left, over here, we've got our components for our very first Raspberry Pi GPIO experiment. So let me just show you what we've got. We've got our breadboard. We've got our GPIO extension board here. We've got a 220 ohm resistor. I don't know if you can see that. It's gonna focus here or not. Come on, camera, focus. Camera doesn't want to focus. We've got two jumpers. And last but not least, we have an LED light. One side is longer than the other. So what we're going to do, and then obviously we've got our Raspberry Pi here. So what we're going to do is we're going to get this all hooked up. Oh, one other thing that we need is this data cable for connection to the Raspberry Pi and to the GPIO extension board. So the first thing we're going to do is there's a wiring diagram that I'll link in the description of this video after I'm done being live, that shows you how to get this all wired up. So I'm going to go ahead and get this wired up first through the bed into the breadboard here. So I'm trying to do this where you can see. Okay, so that's there. And then what we're going to do is we're going to go to pin number 17. You can't really see it there, but so pin number 17 gets a jumper. GPIO 17 right there. And then the ground gets a jumper as well on the other side. How do I know these things? Well, because of the wiring diagram. Let me go to the wiring diagram real quick and I'll show you what I'm talking about here. 2, 3. I'm trying to use my alright, let me see here. Bam. Go there. And so you should see my desktop here momentarily. There we go. So the wiring diagram that we're going to be looking at is here in this tutorial that we've been running on. So it shows us how we need to set up our pin. So the jumper goes from see if I can rotate this here and then zoom in a little bit here. All right, so one wire goes from GPIO 17 down to here to row 28. Our ground goes from 20 to 23. Our LED is hooked up on row B, C, D, E, A, B, C, D, E, and then the longer end goes on the right, or in 24, and in row 23 goes the shorter end of the LED, and then in D26, I mean D24 go, and in D 25, 26, 29, D24 and D29 goes the resistor. Okay, so we're gonna go ahead and do that. So let's see if I can. So let's go ahead and get our wiring set up here. So again, we've got our ground, and what we're going to do is we're going to go from row 25, and I don't know if you can see this on the breadboard or not. It's not the best video camera here, sorry. So the rows and the columns are numbered. You can see on the bottom of the breadboard there is row data with A, B, C, D, E, F, G, H, I, and J. There we go. And then you can see the columns, or those are the columns: A, B, C, D, E, F, G, H, I, J, and then the rows are numbered on the left-hand side. So what we're going to do, following our wiring diagram, is we're going to put our ground in 20 and 23 right there. Wait a minute. Yeah, right there, 23. Okay. We're gonna put our wire from GPIO 17 into 28. 28 right there. Seems a bit off, but and then what we're going to do is we're going to take our LED and put that with the long end of the LED, and we're going to put that right here . That out the way. And then this row, or this this resistor goes right next to the LEDs and on the same row as the positive wire. So from what I read, this wire here is our positive and this is our negative wire. And So we're basically taking power from here to there, transferring it from there to there, into the LED, through the LED, into the ground, and then back through. I believe that's how that should be working. So now we're going to take the breadboard and the Raspberry Pi and line them up. We're going to take our data cable and make sure we've got the right end here. So this only goes in one side there. Hook that up. There we go. We're going to take the other end, which is our Raspberry Pi. Let's go ahead and get that hooked up there too. There we go. So now we have everything hooked up there. So let's go ahead and go back to our desktop, and we're going to open up our Raspberry Pi. We're going to open up Visual Studio Code. This is how I'm choosing to do this. And I'm going to go ahead and open up the recent folder here. Bam. And it's going to be this blink.py right here. And I've been playing around with it. We're going to turn this to 1 second. This is Python code. Save that. Alright, now what we should be able to do is we should be able to run this code, this Python code, on our Raspberry Pi and watch our LED light up as well. So let's see if this works here. Okay, so I need to switch my screen here. I can never remember which screen I'm working on here. So we'll run our code by coming down here. And I made that bigger. Let's just shrink this, well, shall we? Alright, so I'm going to now navigate to where this Python code is at. Code, Python code 01, and it's called blink.py. And so if I type python blink.py and hit enter, what should happen is my LED should start lighting up here momentarily. So I'm going to hit enter. And there it goes. And in the meantime, what's happening is the LED is continuing, while it's continuing to filter on and off, my code is executing in the background here. I'm trying to get this to where you can see my code actually executing here. There we go. So you can see my code is executing and my LED is turning on and off over here. So now let's stop our code from running, Control C, and we're going to change one of the values here. We're going to change this sleep time for these LEDs to 0.125. So let's get like a strobe light thing going on here. Save that. Clear my screen buffer. And I'm going to go ahead and do it again. And our code will execute even faster. And our light is blinking like nuts so right now. And like I said, our code is just flying through right now. It's just doing a loop right now. So let's go ahead and turn off our code once again. Control C. There we go. So let's explain a little bit about what we're looking at here. This is Python code, and this is basically an LED blinker that is using a couple of different functions. It's looping through. Well, first off, what we do is we import the GPIO library for Python and the time library for Python as well. The next thing we do is we define a variable called LED pin. And what that LED pin is doing, as I look at this code here, is it's passing in a value that's based on this number. So we're setting it to 11. I'm not sure how bright we can make that. We can dim it, we can brighten it up. What happens if I put this to 20? And then I save this, and then I run this again. It says the value sent, channel sent is invalid on a Raspberry Pi. You know what? That's why. That's what that is. That's 11. And I just need to understand what these GPIOs are doing here. I'm sure there's a range of numbers that you can do. So the first one is going to be the pin number. And then the second one is going to be a low or a high setting. Yeah. Alrighty. Not to get too anyway, just looking at the Python code. Save that and run that again. Make sure I didn't break that. Yeah. Control C. Okay, there we go. So then what we're doing here is we're setting the pin out and low for the channel, for channel 11. And then out is going to be when you're turning it on, I think, and then the low is turning it off. And then you're doing this loop, and then while the loop is true, which is going to always be true, then it's going to turn the pins on and off. If you hit destroy function, then it does this cleanup where it releases all the GPIO pins from usage. And then this is where you're doing the main program entry. You set up and then you do the loop, and then if you throw a keyboard interrupt exception, then you call this destroy, which then stops all of the GPIOs from executing. So hopefully I kind of explained that. I'm probably way off on that, but again, I'm not a big Python guy. So anyway, yeah. So the next experiment that I believe I'll be running, if I rotate this counterclockwise and I zoom out, the next one I'll be running will be a button where I'm turning the button on. I'm turning the light on and off with a button. So it'll be adding some more stuff in there as well. A couple more resistors, and then a button, and then a couple more jumpers. So there's a jumper here to here, one from here to here, one from here to here to here to here. And so, yeah. Eventually, what I'll be able to do is get this down to a big time one way down here, like this one's using, I think, a motion detector or something like that, or yeah, ultrasonic ranging. It sounds all fancy-fied and everything. So this one's an attitude sensor, and then there's some soldering in there for water flow light or something like that. There's some more code. And then once you do all of those, then they consider you to have some proficiency with working with a Raspberry Pi. So in any case, yep. So that'll be the next one I do, is turning lights on and off with a button. So until next time, God bless, and hope this finds you well. Peace.